All right, we'll get started now. I'm Tom Harris. I work for Edge PLM. I've been working with sheet metal for quite a while, and today what we'll be having a look at is Solid Edge 2020. We'll be having a look at some of what's new in sheet metal and also the new 2D nesting application with Solid Edge. It's quite an exciting new time in Solid Edge. There's a number of improvements in 2020, which I'll just very briefly touch on before we delve right into the sheet metal and 2D nesting. Firstly, the Solid Edge portfolio, as you can see here, is quite extensive. Solid Edge covers everything from mechanical design, which has new solid-based model definition built into that, electrical design, which came out last version, which now includes full electrical routing, wiring design, harness design, and interactive working with Solid Edge, the PCB design and collaboration, which is completely collaborative with the Solid Edge tools. Just getting someone saying they can't hear me. Is anyone else having trouble with the audio? No, I believe the audio is working correctly. It says it's all working. Let me just check. That sounds like it's working. So whoever's having trouble with audio, if you can check your PC setup, it looks like it's probably on your end. So sorry about that. I'll continue on. So the PCB and electrical is fully integrated with the Solid Edge mechanical that we're all used to. Then we've got quite a few advancements in simulation. We have, I'll go into that a little bit more later on. In the manufacturing side, we have Solid Edge Cam Pro, and new in 2020 is the 2D nesting, which we'll go into. We have technical publications, data management, and cloud collaboration now includes augmented reality. So that's quite a nice advancement there. To go into a little bit more detail on some of these, the mechanical design includes augmented reality, which basically allows you to take a smart device and walk around and show people the physical not the physical, but the virtual model of what you've designed in the physical world. You can walk around it, you can position it, you can check it out. It's quite powerful and advanced. Model-based definition takes this to the next level and also allows you to include fully detailed 3D PDF designs. The reverse engineering in mechanical design has had further improvement to allow you to fine-tune the imported mesh-based models. Design for additive manufacturing has also been quite improved, and there are various other core CAD enhancements. Now, with the augmented reality, you can see there's a few pictures here. One of the first picture up the top left-hand corner shows the augmented reality application scanning the surface, the physical surfaces around the phone, and in this case it's a Samsung, and then you just simply tap to place your model onto the floor. You can also scale it and rotate it and things like that and walk around your model. At the moment, as of today, this is available on Android devices from the Google Play Store. That's the Solid Edge Viewer app, but it is not yet available with augmented reality on Apple devices. So just a quick word of warning: if you're running an Apple device, it's not available at this point in time, but it is available for Samsung and Android devices. Also, this is just a quick summary of the electrical capabilities. There has been quite a bit of development since the last version on this. Simulation has had a huge improvement. We now have rigid body motion analysis available with Solid Edge. We have harmonic analysis available with Solid Edge. PCB analysis, checking out your circuits, wiring drops, all of your typical circuitry analysis tools. And you also have flow, both transient and static flow analysis within Solid Edge now as well. So there's quite a few improvements. Nesting we will get onto shortly. Firstly though, what we'll do is we'll move over to the Solid Edge environment. This is just your typical mechanical Solid Edge environment, and this is, you know, quite a large industrial parts washing system designed from a company called WashTec in Mexico. And what we'll be doing today is we'll be having a look at maybe some sheet metal work. We'll create a new cap on top of this model, and we can just toggle on and off the rest of the model, and we can also change the presentation style to something which is a little bit more conducive to actually modeling in Solid Edge. Now we kind of want to create a sheet metal lid or top over this particular part. One of the advancements in Solid Edge sheet metal in this last version is to do with the Lofted Flange command. Now, we have always been able to do lofted flanges, but you'll see from what we get into next is the Lofted Flange command has had substantial improvement. And I just want to draw the top profile. The bottom profile you saw there was already drawn. I'll just draw an additional profile here. You can activate the different parts so that you get everything snapping nicely. I'll add a tangent relationship in here, and we'll give this some dimensions, maybe 700 there, and do we need anything more? I don't believe we need anything more there. So I'll accept that second profile. So we're creating a lofted flange from this bottom profile up to the top profile. Now, what you'll notice in 2020 is the bending method. We've now got substantial improvement on the bending method. The old Solid Edge 19 and below used to be able to do triangulation using bend lines, but the resultant model was not actually changed because of the bend lines. The software just calculated the use of bend lines and where those bend lines should be. New in 2020 is the ability to actually create the lofted flanges with physical bends. Now, we have a number of options. All of these options are new as well. Not all of them. You've always been able to do the number of segments in the arc for the bend lines, but now you've got a few extra options. For example, you can specify the maximum deviation away from the physical arc. So I'll just say maximum chord length, say OK, and we will finish. Whoops, I didn't save my sketch. Let me just do that sketch again. Sorry about that. Just add my tangent back in and use the radial menu to add that dimension there. And I will accept this profile now. However, I'm going to add a little bit more vertex mapping. Now this basically just says this point to this point. Now this point maps over here. I'll add one more, which maps from here to here. Make sure I get the right one. And then I say which side the sheet metal is going to be going. You can see that there it's developed quite a quick, nice profile. And another option in solid edge sheet metal is, sorry, it's not there. Where is it? To do with these bend relief. Oh, here it is, sorry, missed it. Typically, you have auto relief options around these bends where they are nested closely together. You need to generate relief, otherwise all of the bends try and join in one place and it really doesn't work. So we have two auto relief options now, linear and spherical. Spherical in the flat pattern gives you a nice clean circle in the flat pattern. So that's quite a nice option with the lofted flange. You can see that it generates your actual lofted flange. Now you'll notice, I don't actually want to put a flange on here, but you'll notice I can put a flange on any of these edges now. If I was using the old bend triangulation method, just the bend lines, then I would not have been able to put that flange. So we'll continue on. We'll grab, I'll put a flange on the bottom here first. Might want to come in, for example, 35 mil. And depending on, I'll just show the rest of the model so I can make sure this lines up. Depending on my method, I can choose where the bend goes so that it lines up and sits correctly with respect to the rest of the model. So that's how I want that. Whoops. Position that bend there, and then I want to do one more bend on this edge. Now I don't want that to be 90 degrees. I want that to be somewhere around 120 degrees. And if I change my view to the back, I can bring it out what looks like about 52 millimeters, so that it lines up nicely with the side there. Additionally, I can do two bend corner just to make that nice and clean joint. Lastly, obviously I want all of those things on the other side as well. So I'll select what I just created, mirror copy the feature, and I will mirror that about the, make sure I get my plane right, about that plane. And you can see I've now got quite a well-developed lofted flange with a few extra features and fasteners there. Now, as with solid edge, you've always been able to flatten the parts. I can simply say flatten. I'll flatten it based on this face. And there is my flat patterned part, ready to go, as you would expect from a reasonable CAD sheet metal package. So we've got a number of things we can do in the sheet metal environment. And I just want to show you also quickly another option you have. I should have stayed in the sheet metal environment. Another option you have in sheet metal, and that is part costing. Now, part costing was introduced in 2019, but you've got a little tab here called Design for Cost. If you know and this will of course vary depending on your suppliers and how you're manufacturing, the cost for each of the features. You might have a surface cost, you might have a mass cost. In this case, I've got a small cut cost, in other words, to cover laser cutting, and I've got a cost per bend, and you can see the cost units, and it gives you an estimated cost for my sheet metal part that basically helps me design with the end product and the manufacturing of this product in mind. So keep that in mind when you're designing with solid edge. When you're designing sheet metal with solid edge, you can design for cost, keeping that in mind. Now, when that was all I was going to show with the sheet metal. When we come to actually needing to manufacture things, it helps if we can very quickly find out how many of each type of part we've got. Okay, now that comes in with the select tools. I can do individual part searches, or I can save queries. Now you can see here I've got a couple of queries set up. Inox is a material, and 1.5 millimeter shows me any parts that are made of inox with 1.5 millimeter. I can simply copy that and paste. I've got a new query based on that, which I now want to edit. And I'll call this stainless 1.98 millimeters, because obviously I wanted to create a query for stainless steel using 1.98 millimeters. So I'm going to have to change both material contains inox and material thickness is 1.5 millimeters. How do I do that? Well, these are the properties. Now, you'll notice material is right there, contains, and I just type stainless, add that to the list. Now, I don't want inox to stay in there. Notice, however, there's also a query based on material thickness. There's no list for material thickness. What that is it's a custom file property. And I can get to these using custom file, and then I just simply type material thickness. Now, this has to be set up correctly to expose your part variables as this custom file property, and that you typically set that up in your template. 1.98 millimeters. Add that to the list and remove my 1.5 millimeters. Okay, so I have a query there set up for stainless steel 1.98 millimeters. Double click on it and it runs that query, and these are the parts. Notice there's 44 items selected that use 1.98 millimeter stainless steel. This becomes important shortly, and I'll show you why. Because what we want to do now is I want to switch over to the new solid edge sheet metal nesting application. I'll just start sheet metal nesting. You'll notice in Tools, Solid Edge 2D Nesting. Obviously, you need a license for nesting, and it opens this application here. Now you can save your nests, which save all of the details. Because we're doing a demo here, I'll show you how to do a new one. There's also a getting started video, which is quite useful. I'll say I want to create a new nest, and this tab here is the parts. You work from left to right. How do I want to bring my parts in? I want to import solid edge parts. This opens up just a normal browser. At the moment, for example, it's searching in a folder called WashTech, which is this project's folder. And what I want to do, and I can, because my material and properties are all searchable now, I can say material, name, stainless, space, material, thickness, hopefully I've spelt this right, 1.98 millimeters. Okay, and immediately you see a list of parts that are here in this directory or subdirectories, which I can select from. Okay, I don't actually want this part because there's a duplicate there. I'll just select all of those parts and say open. Now, you might be wondering what it's doing. It tells you. It's converting the files from solid edge sheet metal format into a nesting file. It analyzes each part and all of the lines of the parts and basically creates a file in the nesting ready for import, and it's analyzing the files as it's going. So yes, it does take a few seconds for each part, but the downstream results of this is that you don't have to fluff around trying to fix up your DXFs and your models. You can, once you've got these in and correctly, you can use the analysis results and you can generate your nests, which will work very quickly and very easily. So it is well and truly worth giving it the time to actually generate these. And to be fair, this is probably the most time-intensive part of the nesting program, and it's doing it relatively quickly. So this, at the moment, is the CAD File Importer. This isn't actually the nesting program at this point. Now you'll see down on the bottom left hand, there's key global settings and there's various keys to the files that will be shown in this list very shortly. Basically, it can have the drawing loaded. It can use all of the geometry in the drawing. Sometimes it will only use some of the geometry. If there is an error, you may need to, change which layers you're using or something like that. It will show up. If there is not a flat pattern present in the part, it will warn you of that during the import process, as you see there. Actually, I do need to bring in one additional file. Sorry, that one that I cancelled. I'll bring that one in as well. So these are the parts, the sheet metal stainless steel 1.98 millimeter parts from the WashTec model that we've been looking at. Now you'll notice that it's actually done what looks like a pretty good job. Most of these parts are all looking pretty good. There's a few things that you want to see. This is the original CAD file. This is the part that will be produced, and if there's multiple parts in the one DXF, it will list them all down here. We've also got layer and color assignments and what to do with each of these layers. This does actually become important, and I believe we'll find one or two files in here which it's important for. Now, this particular part, you'll notice that it's got both, I hope you can see that, it's quite difficult to see on my screen, a light green interior loops layer and outer loops layer. Then I've got a refined interior loop and a refined outer loop. If I zoom in to this part, you'll see, and this is quite common in other CAD systems that don't cut parts normal to the sheet metal, is you get angled cuts. Most of the time, especially if you're laser cutting, water jet's a little bit different, but if you're laser cutting, you only want the outer profile of this line. I'll just show you some of the options that we have in Solid Edge. Notice if I ignore everything, I don't get an imported part. I'll say I want to cut the outer loops, and notice it's got all of these edges as outer loop parts. Basically, it can't work out what to do with those outer loops. However, with the interior loops, because it can't create a single piece out of the outer loops, it says, all right, I recognize that I can create a piece out of this. So with Solid Edge, you have the refined inner loops and the refined outer loops. And these are quite critical because you can then, as you can see, create or cut more difficult parts like this very, very simply. And depending on your layer assignment, it will do this automatically. You'll notice that this was the automatic option. I can also set the options globally. Okay, I might say actually globally I want to ignore the inner loop, and globally I want to cut the refined outer loop, and it will remember these settings for the next time you import parts. So we're doing pretty well so far. However, I also may need to add some DXF files as well. So I'll also import CAD. Oops, no, sorry, DXF is the next window. So I've got all of my parts ready to import. You'll notice that some are orange. Where you've got things that basically come down to an infinitely small edge, you'll often get that type of warning in there. So I'll submit this. It brings the parts into the nesting program. I'll just maximize that. And you'll see that each of the parts has a series of properties and your dimensions. I'll also bring in a DXF part. Now, I'll remove that, and we'll say in WashTech there are some DXF parts as well. I'll just bring them both in. Notice the layers on these are different, so I'll actually change to cut the interior and cut the exterior. Oops, that's not exterior, that one is. Now you'll notice that there's another option here, attach, and I should have shown you that with the last one. This is where the DXF, for example, bend lines are attached onto the DXF model, but it's not actually a cut process. So we'll bring those two parts in there as well. Now, these are all of your parts at the moment. You can see that they're all listing quantity 1. Okay, and that's where your querying can be quite beneficial in Solid Edge. You set your query, and then I can simply run a report of the parts currently selected, and I'll choose to check the format. This is a summary of the atomic parts selected, and notice it's got the quantity of those parts. I'll just make sure there's a sort on here, so it makes it easier for me. Sort by the document number, and yeah, that'll do. So I've now got my document number and my part quantities. Switch back here, and you see these pretty much line up. Now, this one didn't have a flat pattern, which is why it's not showing up here. I'll just quickly modify some of these parts to make sure that they line up with how many I need on my job. And of course, I don't have to make these line up with, a quantity of 1 on my job. I can always 55 down to 61, just making sure I get this right. 55 down to 61. Notice I can edit things just by simply selecting multiple at a time. And that's all. So what I've got here now is a quantity list of one machine. If, for example, I need to make 3 machines, okay, I'm just going to sort by quantity, and that gives me the option to select all of these, edit quantity, 3. It's changed all of the ones that were, whoops, except I didn't actually select them all. I'll do that shortly. 6. Does help if you actually select them all. Okay, so now I have a series of different quantities, or the quantities for 3 different machines. Okay, I also have dimension X and dimension Y. This is calculated, and I can sort by these. This is calculated based on the DXF that's imported. You can see I've got some fairly big parts, some over 2 meters, 2.9. With Y, I've got up to 1.47 meters size. So I've got quite a few parts in there that are pretty large. That comes into play when we go into the sheets. This is your cutting sheets, okay? You have standard sheets. You can edit your standard sheet sizes. You can also add non-standard sheet sizes just by typing in the values. This is really good for using up offcuts and things like that. I'll just use all of my standard sheet sizes, and you can say how many you have in stock, so it won't use sheets that you don't have in stock. You can get the jobs out. Next, we go to nesting, and very simply I can just say start. It quickly has a look at the parts, how many are needed, and tries to start laying them out so that it will use or waste the least amount of material. However, you'll see over here the nest repeats, best efficiency, balanced repeats, and prefer repeats. This is to do with the amount of work needed to actually create the nesting for these parts. Where it's running best efficiency, you will typically get not many repeats of the nesting. So you get elevated nesting time, which is programming time that you need to set up your machines. It's elevated, but you get very, very high efficiency with your nesting. Now you'll notice that there's a gap down the side of this sheet. I might not want a gap down the side of the sheet. I might want a gap up the top of the sheets. Okay, I'll just quickly stop this run. Notice I've got nesting direction. I can change my nesting direction. And what this does, you'll notice, now it leaves gap, or leaves the offcut in the direction that you've chosen. But now I've got 12 sheets and 11 nests. Okay, so I'm using a fair few sheets, fair bit of programming time. It's actually worked out a better way now, 11 sheets, 11 nests, and it's running up to about a little bit over 82.5% efficiency. I can also run a nesting for a fixed amount of time. If you do not say a fixed run, it will continue running and continue trying to find improvements on, in this case, the efficiency of your model. Okay, I may not want that. I might want to only give it 2 minutes, for example, to find maximum efficiency. However, there's some other settings I want to show you before we continue on. Now, you'll notice, particularly in part rotation, this has a huge impact. If you have material which is, the parts need to be created in the right orientation for the grain, okay, I can select and say, no, I cannot rotate these parts in any direction. Okay, that's a 0 rotation. However, also useful for grain control is the 180-degree rotation. It can flip it 180 degrees, still nest it. For example, these two are basically flipped 180 degrees, if you can see my cursor. But it will not do anything more than that. If, one other thing I should mention, we're talking about grain direction. The zero rotation is as it's imported. Now, if I don't want that to be my zero rotation, for example, maybe this part should be sideways all the time, okay? Then I just simply select, and I can do this with one or more parts, choose my rotation and say, okay, that sets the rotation for that particular part. And now, if I run this nest, you'll notice that these parts, because I've got 180 degrees, can go in one of two orientations. However, you may see as well, I'll just stop this, we've also got unplaced parts. Now, the reason we may have unplaced parts is because they may exceed the sheet size in a particular direction. You can see 1653. Let's go have a look at this part. 1653. There it is. Now, notice that's 2 meters and 65 in the X direction, 392 in the Y. 2 meters and 65 exceeds the X direction dimension for my sheets, for all of the sheets I have available. It could place them in the Y direction if I allow other rotations. For example, I can say I will allow up to 90-degree rotations. What this does now is it can rotate these parts in 90-degree increments to fit them. Notice I have no unplaced parts in the bottom of my list anymore. All of the parts are placed on my sheets. If I need a little bit more specific control, I can choose a different option called Advanced. I'll come back to that. Additional settings here, though, is if I want to allow 90 degrees plus or minus 5 degrees, I can add a 5-degree tilt allowance. And I can also choose whether or not to allow the parts to be mirrored on the sheet. Again, this, you probably don't want to allow mirroring if you're running a veneer or something that has sides. But if you're just running sheet metal that's the same on both sides, you would allow mirroring for potentially better nesting quality. So there's various options, and you can control that as a global nesting setting here. If you do not want to control it as a global setting, I can switch to a detailed grid, and now you'll notice allowed rotation, allowed tilt, mirror, priority of parts. I have my control per part now, and I can do this as needed. If I want to, for example, maybe this particular part, I don't want that to be a 90-degree rotation. It can only rotate 180 degrees. Maybe these parts here, I will allow them to be mirrored as well. Allow them to be mirrored, and maybe they have to be, maybe I'll also allow them to have up to a 10-degree tilt. So now I've got very, very specific control over what the nesting is allowed to do. Obviously, all of the additional controls I add reduce the amount or the maximum efficiency I can get. So you can see running about 82.5 or just below 82.5 with those additional controls. Now, there's two other options that I want to show you as well. I'll just stop this one. Part spacing. Obviously, if you're running a nice new laser cutter with a 1 mil cut, you probably don't need an 8mm part spacing between the parts and an 8mm spacing to the side of the sheet. You can probably reduce these, maybe 5 and 5. I won't change anything else, and I'll just restart. Notice 82.4. Restart my nesting. My nesting efficiency is automatically higher because I'm reducing the amount of waste between my parts. I'm now running up to 83.51. Before it gets to a minute, it's got 40 seconds remaining. And you can see a graph showing the nesting efficiency as it's progressing along. Now, if I want to have a look back, I can just simply click on any of these nests, and I can choose any of these nests. They may not be the most efficient that you desire, but I can pick and choose whichever I want in my nesting. This comes into play a lot more when you actually also start using the repeats options. That's now finished. It'll stop this and save those settings. 83.88% efficiency was the highest percent efficiency when I was seeking best efficiency. Maybe instead of seeking best efficiency, maybe in my manufacturing environment, it takes a fair bit of time for me to re-nest or set up a machine for a different run. And obviously this will, which you choose will depend on the size of the run you're doing as well. But maybe I want to spend less time programming my machine and more time doing other jobs. I can choose balanced repeats. Keep in mind 83.88. Now, see how I'm getting 3, 3, and 3. Each of these sheets will be repeated 3 times because I've told it now that I would prefer to have less nests and at the cost of efficiency a little bit. It's dropped the efficiency down to 81.83. But the beauty of this is that it allows me to prioritize my nesting time over my efficiency. It will still continue seeking the best nesting and the best efficiency for that number of nests. It will continue to seek this as long as you give it with either the fixed length run or just running it until you come back and say stop. Now it's managed to get up to 81.84% efficiency with only 4 nests, which is not a bad option. Okay. However, I also have an option to seek very good efficiency and prioritize nesting as well. If I choose that and let it run, see, it's not prioritizing nesting as high as prefer repeats. It's not prioritizing efficiency as high. It's trying to find a good balance between the nesting efficiency and the number of nests it creates. And you can see that it's already exceeded the nesting efficiency that we achieved with the prefer repeats option, but it hasn't quite got up to the efficiency when we said prefer best efficiency. So it gives you a balance between the two options. And it seems to be doing pretty well. It's up to 83.47% utilization. Now, I should also mention the percentage utilization does not include this offcut, the scrap offcut. It only includes all of these little bits of offcut here. Now, we can have a look at the nesting as we go. I can click on any of these parts and that it will highlight not just where they are on that sheet. You see that part there highlights here and here. So it shows you the distribution through my nesting as I go. And I can always go back and choose a different nest to use if I want. Whichever one is selected at the point where I move to the next tab is the one that you will be, in this case, exporting. And of course you can export to Solid Edge, which will basically create the DXF and bring the DXF back into Solid Edge, which is beneficial if you're using something like Solid Edge CAM in order to program your cutter. If you're not using CAM, then pretty much the default is DWG or DXF, and so you can choose to create or export the nest. You can choose to put each part on a single layer. You can choose your nest orientation. You can output the sheet border as well. I can output to a single file with all of the nests, or I can output to multiple files. It all just depends on how you like to process things downstream, or basically generate your G-code from the DXFs. And then you can export using all of the different options, loop directions, as well as your units. Lastly, your DXF version, and then you hit export. It will go and say, what do you want to call this? I will call this stainless nest 1.98 millimeter 5th of December for the Waste Tech machine. Oh, sorry, I'm still in a, there we go, save, still in a search. Now, one other thing you can generate, and this is quite important, is your nesting reports. This summary report is a very, very basic report. The parts, the quantities, the material used, number of nests and number of sheets, and the total number of parts created that will be cut from that. Well, next, however, you've got the detailed report, and this is quite a useful report for the guys on the shop floor who want to be able to recognize what part is what in your nest, and basically how to process and continue. Notice the watermark shows ×3. There's 3 of these sheets, so quantity in nest produced by that nest, total in job. So it gives you all of the details and lets you print all of your, basically your workshop documentation to go with your nesting. So, quick summary, I import my parts. I can use a detailed grid or a basic grid, depending on whether I want to set global nesting options or part-by-part nesting options. I choose my sheets. I can add custom sheet sizes to use my offcuts. I can choose my nesting priorities and my nesting preferences, spacing, all of that nesting directions. So I can use this if I've got sided parts or sided sheets. I can also use this if I've got grain dependent sheets, and I can choose how to export my parts as well. Lastly, if I need to save this, and that is quite a beneficial thing, I'll do this. WashTech, it's another nest. WashTech machine, 5th of December 19, stainless steel, 1.98. So I can save this file off, and that lets me come back and maybe choose a different nest option. I can basically do whatever I need to do very, very quickly from the nesting software. So that's Solid Edge 2D nesting. We think it's quite a powerful and good option. If you have any questions about anything you've seen today, because this is an online webinar, we've had people trying to answer the questions as we go. We will answer them offline, but because this is online, if you have any questions, either now or later when you watch this video, please send them through to info@edgeplm.com.au, or you can ring either our Australian phone number or our New Zealand phone number listed on the bottom there, 1300 883 653 for those in Australia, and 0800 440 684 for those in New Zealand. So thank you very much for watching our webinar, and we will get back to you offline if you've submitted any questions here that haven't yet been answered. Thank you. We have recorded this and we'll be posting it as well.